And yeah, once again, thank you for joining. The session today is about what kind of options does Azure present when it comes to containers? What can you do and how can you run effectively with containers? Now, this this here is an intersection of two nice technologies, right? One is cloud, which gives you on-demand compute. The other is containers, which kind of gives you it kind of saves you from that version hell or on getting like so much installed on your machine that you end up formatting it like after 2 years or just changing the computer altogether because it gets so much slow, right? Two exciting technologies and they can complement each other. And that's kind of, but during work, I've seen that there's a lot of confusions about what kind of options are available, right? And that's kind of what we're here to talk about. Um, just a quick refresher for the unannounced. A container is basically a list of instructions with a base operating system image that makes sure that everything is isolated in a bubble, sort of. And all the runtime and codes and system tools and libraries that are required to run something as code is available in that isolation without affecting the environment around it. So theoretically and practically too, you can run a number of containers on the same virtual machine. So I can have Python 3.11, 3.14, 3.13 all running together without conflicting each other. The When containers were introduced, it was very popular that the term that it works on my computer now is universal, because it would work on your computer because we have the same runtime and code and everything. Uh, that does not depend on what is installed on your computer. As long as you have a Docker runtime or a container runtime, Docker is one of those companies that provides those container runtimes. You can run a container on your machine. Eventually, this thing migrated to cloud, so you could run these things on cloud too. Yeah. So just a summary, everything in a single package, runs everywhere, laptop, data center, cloud, the same structure, the same file, the Docker file, the same containerization works everywhere. And now more so ever. The application are isolated and they are few resources that it takes up. It doesn't take up everything. And for the security professional, that means less security surface, right? That's very essential. You contain the blast radius. That's kind of why these things are important in service-based architecture. What I mean basically is that in a virtual machine, basically everything touches your hardware. So if an application can compromise your hardware, it compromises everything on the server, on the machine. But on containers, the blast radius is very small. So all of it is contained in a single sort of isolation. That isolation makes sure things don't creep out unless and until you want them to. Okay, going back. Right. So that's how it looks. So there's hardware infrastructure, there's operating system, there's container software, which is usually Docker, and then there are Docker D or Docker containers available on top, which in terms of virtual machine touches direct hardware. Um, that's basically it. Now we go on to the topic of today, the Azure ecosystem. Azure gives you a lot of options, and that's good and bad too, because a lot of things they do overlap, right? There are options to run almost everything, and there's no one-to-one match. There's mostly many-to-one match, which creates an obvious confusion, and that kind of gives you an opportunity to explore new stuff and do new things, but sometimes it's easier to understand the fundamentals. The session basically tries to explore from a bird's eye view what options to go for in which cases. And this is not a hard, fast rule, but just an experience. There are web applications that are especially used for HTTP and HTTPS service. Web apps, basically, there's Kubernetes, the almighty Kubernetes, which can run, orchestrate, and manage a number of containers in production level. There's a whole bunch of detail that you can go through. You can map drives. You can have secret management. You can have different type of networkings. In all, what I'm trying to say, highly technical, but very powerful. There are virtual machines, just like your laptops and workstations. You can run Docker as a software. If you have Ubuntu, you have a container runtime. Sorry, Linux, you have container runtime that you could use for Docker containers. Fun fact, Dockers run best on Linux. Yeah. So most of the people or most of the companies you will notice, they do run Linux machines in case these things have to be done. Most containers are Linux based, right? Then there are container apps, which basically have an extended sort of range like Kubernetes, but they don't have the depth of Kubernetes as a management. So if you want like highly fine-grained control, that's Kubernetes for you. A little bit coarse, that's container apps for you. We go into details in a bit, just giving you an overview. Then there are certain services which are not directly related to containers, but can be run like batch OpenShift. OpenShift is container based, so but that's not directly Azure. There are Spring apps you could run. There are fabrics you can run on this, function apps similar to app services, and then there are container instances. We're going to talk about app services, container instances, container apps, and a little bit about virtual machines because those are the core services that can be one-to-one related to containers, specifically designed for containers. Virtual machines are designed for everything, so kind of there for all of it. Yeah. Let's start with container instances. They're very good to run a single container or a container group like a sidecar container with it, right? There's no orchestration, there is no cluster management, there's no jargon around it. You need a container, you run a container. Simple. These are used for simple jobs, burst jobs like batch jobs, dev test testing, and scenarios where you just need to run something and go away with it. You do not want to manage the infrastructure. You do not want to create a plan or anything about that, right? These are very fast startups. There's no infrastructure to manage. But on the other side, for the geeks, there is no orchestration. There are limited scaling features, right? So, yeah, this is a starter option. In my opinion, that's very nice to check if your application does work up there without setting the whole thing up. Then there are app services. The almighty app services deal with everything web application. So if your container has an endpoint, a web application endpoint, that's awesome because web apps can run it. So can function apps. They're built-in scaling, SSL, CI/CD pipeline compatible. They're very well suited for web apps, APIs, and teams that are familiar with app services will find them at home. There's minimal infrastructure requirement because you have to create a plan. You need to know which kind of plan it is. A plan kind of works like a virtual machine. So if it's a Linux container that you're trying to run, it's nice to have a Linux plan, right? Uh, and each of these plans, they give you a little bit more control over how much capacity and capability is there. So you can decide on how much RAM and how much, I mean, not exactly RAM, but there are um, quantified levels of what kind of capacity you get, the storage and the compute power. They're very simple also. They have very strong integration with monitoring and scaling, which is very important if you want to monitor these things. If they restart, if they fail and stuff, right? There's less control over the runtimes. They're totally web focused. So in case you have a container that does not run on HTTP, HTTPS, that you might want to try other options. Then there is Azure Kubernetes Service. The almighty Kubernetes Service gives you a huge platform that sometimes, in fact, most of the times needs its own team to be managed, right? Azure makes it a little bit easier so that the management plane is a lot easier to manage. A lot of things are automated, but still it's a huge commitment. This only happens in production, and it's very useful when it goes to productions for disaster recovery, for logging and monitoring, and all of it. There are when you talk about microservice-based architecture, this is what people talk about most of the time. These are complex containerized applications. They talk to each other both internally, externally. They're highly scalable production workloads that are run on this. The pro is that you get full Kubernetes power. If you've never tried Kubernetes, you probably should try Kubernetes. Then you have a bit more appreciation about the container system and the power they have. They have very fine control, gain controlled over what can who do. So from deployment to the type of deployment, the pods, the containers, and the whole system of Kubernetes is very layered, and it's a very large ecosystem. And it's not isolated. They have a huge community around it. It's an open source project that has been adapted in Azure. They have a huge community of very useful tools that could be useful to troubleshoot, that could be useful to make new things around it. Uh, they are very operationally complex. They have a huge learning curve, very steep. Then there is the sweet spot in between. That's container apps. It's a serverless container platform. Would feel familiar like Kubernetes because you can run different containers in it, and they can talk to each other. You can mount volumes. Some of them can be internal, some of them can be external. A lot of it is just abstracted, but it is built on Kubernetes. A very simplified version. So good for small teams, small companies getting started with production workloads before you move to full-blown Kubernetes. They're event-driven apps. API background services can work, and microservices that may not be compatible to Kubernetes can still run on this. Good thing there is no cluster management. Auto scaling works. Distributed application runtimes is there, so you can have a sidecar container that talks to the cloud, and your containers don't have to directly talk to everything else. So there's a security layer that you can maintain. And there is Kubernetes event-driven auto scaling, which is why Kubernetes is very famous. You can have event-driven automation to scale Kubernetes more or less, but it gives you less control than AKS, and it's a newer service. So there might be support or there might be code that is still in progress. Not saying that there is because I've used it, but just a disclaimer. Let's go to a demo. Because we have less time, I've deployed some resources already. Just and it's not that difficult. I could probably take you through some. So, as I said, container instance is basically running a container, and that's what this is. I give it a DNS label and I create one command and say, look, pull this image from the Microsoft repository and create a container that is running on Azure and give this DNS name to it, and this port is open. This is the capacity. If you notice, there's no plan, nothing else. I've just set it to create a container and I've given the capacity right there and then. And it just goes ahead, and that's all that you have to do. Then we have this. We have my container, and this is the FQDN you can go through. Um, yeah, well, uh, so Cisco kind of blocked the whole thing. The point here is that the URL does navigate. Yeah, so it's a simple way to go to too many tabs, too many tabs. Um, Simple way to just run a container to see if whatever is running on your machine does that go through for the cloud. It's a quick sanity check. And there's a lot of things that you can do. You can actually talk to other services through managed identity. As you can see, there's not much you can play with, right? Good to have, not to keep for production, but sanity checks and pre-production and stuff. That's that's uh, that's why this is yeah, this is important. If you have to have a system now, because this is not how production works. You don't work with one container, you work with many containers. You work with different applications running in different containers. You want these applications to talk to each other. Having these applications all in their own container, having their own FQD and navigatable on the internet doesn't really solve the purpose, does it now? That's why the container apps, as I explained before, comes into the picture. Now, created created two environments just to show you something. But before I go there, I want to take you through web applications because these are very famous for some reason. Some people really want to have their web apps into a Docker container and run it on web applications because they support best of both worlds. They have HTTPS and HTTP capability, and then they run containers too. It's very important to know that this service kind of is jack of many trades, and that's why if we go here on app services and just try and create one, um, yeah, random stuff because all of us have done it at some point of time. So this is how you do it. You just define the kind of backend you need, the kind of plan you need. So if I'm running an operating system of a container that's Linux, then I choose Linux here. Let's go up. Yeah, it creates a plan, and the next page it asks you what kind of container do you need. You can have your own container registry, which is another component of this ecosystem that you can have. When you have, I'll take you through one of them in a minute. But the point here is that in case you have created containers in your own environment that have taken their own life, you can store them in your own container registry. Every container is referred from some kind of a registry. Docker Hub is a registry. Microsoft's container registry is another registry. You can have one for your own. And that is where this thing comes in. This is the container registry, and it's not just for containers. The repository can have various other artifacts that can have SBOM too. Yeah, software bill of materials. So this is where when your pipeline registers a Docker container and pushes it, this is where you can push it to keep it private. You can associate a networking with it, make sure the public access is disabled. But unfortunately, the price is for premium. So it needs a certain consumption to justify that cost at times. But it is possible to keep all of them private and all of your containers in-house. And that's where you can refer it here. You can select your own registry and refer to the image that you want to go for it. And usually how the access happens is that you create a managed identity for this web app, and the web app's managed identity is given permission to list container images from the container registry. And unfortunately, that most of the time doesn't support RBAC. So you'll have to rely on, sorry, I was thinking about Key Vault. Yes, this one relies on RBAC. So yeah, that's what you can do here. I, for one, have deployed Hello World from Docker Hub. So you can just say Docker hello LD. That's the image. That is the name that you take, and you put it here. And this will take it from a public repository, and that goes for Docker. Then that's okay. I just replace the name at both the places of the image. So it gives me hello world right there. After that, you can set up networking if you want it private or if you want public, or you can have network integrations for it to go through your network for outbound connections. When you submit publish, this is what you end up with. Mm, Something like this, which is running a container, has its own capacity plan, and can be accessed through the internet if you've allowed it. Not surprising, demo gods. But my point is, web app is something to consider when you do this because it supports scaling and HTTP, and most of the services are HTTP, and HTTP is supporting now. The final one is um, apps, container apps. And the best part is it supports an environment. What I mean by environment is that when you create a container apps environment, it gives you a private region where the containers can see each other by default. If you make the container ingress as private, only the containers within the environment can see each other then. If you make it public, then the endpoint goes out, and the services outside the environment can also see it. This is a very, very important concept because when you deploy service level architecture, these small details would really help you out here. And that's where container apps environment kind of shines, is gaining popularity too. If you notice here, it gives you access to volumes, one central region where you can mount a volume and share it with all the containers in the environment. Very handy, very easy to manage. You have networking capacity where you can manage the networking for all these containers together here. If you disable public access, it just gets disabled for everyone. You can centrally manage certificates for all these applications too, all these apps too. And it's kind of a you can consider it and its own system that's trying to brew the environments around it. The apps are the components that are present in this system. Why this is important is because right now Docker is kind of involved in a lot of AI, and so is every company else. You want to keep your model, your data very private, and that's why these container apps having their own environment serve this purpose of the modern 2026 enterprise system where everybody's going to AI. This is a great way to keep your AI structure in as private. What I've done is I've deployed two container apps. One is Olama. If for those of you who are not familiar, Olama gives you ability to download and run various models. And I've deployed an open UI front end to work with those models. Yeah. So when you go there and click on it, it kind of gives you this open web UI. I've already logged in, so I can take you here. And if you notice, I've connected both of them. So when I go to here connections, you will see it's connected to Olama and it's working with localhost. Now the localhost works here because both these are in the same environment, right? And that's why the Olama container can still be private. The egress doesn't have to be there. It doesn't have to be accessible from the internet, but the open web UI is accessible through the internet. So now I can work with Olama. Olama manages my models. Open web UI gives me access to those models to work with it. I go to connections here. I type the model name. I typed 5.4. It's a small model, and I have fat fingers. Yeah, so if you see, it kind of starts downloading everything, but I've already done it, so there's no point wasting time. It's here. I go to a new chat. I start typing hello, and now this depends on the kind of model you have. This depends on the number of parameters it has rumped. Today is not a good day. Just a second. I'll reinitialize it. The best part about containers, you can always kill them and come back. This is not enterprise, so you can say anything here. That's at that.com. Getting this into enterprise is a separate discussion altogether. But and you can find all the models that I am referring to at olama.com. So once it gets there, probably settings, connection, and if you see, the other one had the Olama and Open Web UI in the same container. Let me just show you that would make more sense. So that's why I've deployed two of them. So I go to Olama, the Olama environment, which is a container apps environment. I've deployed in the same pod. Now, for those of you familiar with Kubernetes, pod is an encapsulation of containers. So a pod can run a number of containers, but these containers, they behave like they're on the same machine. A different pod is like a different machine. It's not essentially a machine. A number of pods can run on the same machine. It gets a very encapsulating. So it's important to read about this before you get into Kubernetes. And when you go to revisions and replicas, you would see I have one revision running, and uh, go yeah, and that pod is running two containers together, which is not ideal. In containers, in pods, usually one container should run so that it's all isolated and everything. But that was my attempt to show you that it's possible to do it together so that you can have both of them referred locally. So in the first one, you see that the Olama container was referring to each other as localhost. But now here, it has its own internal service getting on, right? You see, the Olama container now is in a separate pod. So both of them are running in a different pod altogether. When I go to version 2 and when I go to apps, you see there are two apps now. And both of them are running different things. One app is basically like a pod, and it's running just like Kubernetes runs altogether. So now I have these two apps separated. They are not on the same execution field. That's why they refer to each other as a service. This first one here is it's limited to just container apps environment. So it won't talk to anybody outside. So this service here for Olama is not available outside the app service environment, the container service environment. But Olama front end, that has a different story. Um, yeah, so it's accepting traffic from everywhere. So this web UI can talk to the service that's internal, but everybody else needs to talk to this service. So did we download the model? Maybe I need to give a little bit more capacity, but what happens here is that it's going to talk to Olama and the way we downloaded the model before, the same way we can download model and chat with it. The models are available here at Olama. Um, while this happens, let me get back to the presentation and take you through something of a diagram here. Microsoft has a diagram service about the compute, the kind of compute that you want to take up, depending on what kind of workloads there are. And some parts of it that are highlighted, if you notice, are for containers. So this is sort of a decision tree, a rudimentary decision tree for the compute service that you want to be involved with in case, depending on what kind of resources do you want to run. So if you notice here, container apps, you don't need all the Kubernetes services, but you still need some capacity of managing how many containers and what kind of environment do you run. The contrast is what I showed you just in a minute ago. So you can run both of them together, or you can have them as a separate service. So other services can also utilize this without disturbing Olama or any other container that is running with it for scaling purposes. A very simple feature comparison. If you want like full orchestration, full auto scaling and everything, you want to scale and you want to have full infrastructure control, go for AKS. If you are not so obsessed with that level of control, container apps works wonders. If you just want to give it a try, ACI or Azure Container Instance is amazing. And app services is here because most of the web apps or APIs are now being developed as containers because of that problem that it works on my machine and it doesn't work on your machine. You open a port 80 or 8080 and put it behind a firewall, you have an app service that runs flawlessly with everything else. Yeah. What should you do if you, the same thing that I shared before, if you have a short-lived workload, use ACI. If you have web hosting, use app services. If you want Kubernetes, but without Kubernetes, if you still want event-driven workload expansion and contraction of apps, container apps. Otherwise, AKS is amazing as always. This is operational cost, a couple of links that I'll be forwarding you to for you to practice. My name is Mohit Sharma. I am an enterprise architect and I am part of two user groups too. And you can find me on LinkedIn also. And this is failing to get the models. I'll just try once again. If it doesn't work, then that's the end of my presentation. I think there's a capacity problem here.
Maybe while we wait, we can ask if there are any questions from the audience. Feel free to
Sure.
raise
If
your
there's any
hand or
questions,
whatever.
please shoot.
I can start. So the container apps. How you do the environment itself? Do you? It's not like a namespace and it's not a full cluster, but how do you compare it to? Uh, I'm specifically talking about container apps and environments that you have to create, right? And do you get your own compute uh, for one environment, or how is it?
You get your own compute and you can scale up and scale down these computes. It kind of is comparable to namespaces because an environment is it's trying to behave like a namespace. It has volumes associated to it, and you can also have secrets associated to it. It it's not completely there, but it's like almost there.
Yeah, but it's a mix and match between a cluster and a namespace. So it's a namespace with its own kind of resources,
Mhm.
compute resources and stuff. Is that kind of correct? Who knows?
Yeah, yeah.
There's a question from Eskil in the chat about a lot of examples handed web ingress is my options if I would deploy a container workload listening to a UDP port.
Okay, let me.
I'm not sure
Uh,
whether container apps support UDP. You can do it on AKS, obviously, or any vanilla Kubernetes cluster, but
yeah, I don't think I've done the UDP port. I'm sorry, man. I I've mostly worked with web applications and web services. I don't remember that. So maybe that's not what I can answer.
the one of Eskil, if you want to pitch in, is
But
it like external to the internet UDP or is it internal to the network? That's also a difference
mm,
because
we can have different ports, but I'm not sure about the UDP port though. TCP works fine.
Yeah, hi. There is, yeah. The question was really broad. There was just, yeah, UDP, like Rabbit MQ as a listener that's using UDP. And yeah, I noticed a lot of the different container options in Azure support TCP connections, but they have a limitation that UDP is not supported. So I uh, I ended up going deploying it in AKS,
yeah,
uh,
exactly.
but it was sort of overkill. So yeah, just wondering if anyone had any experiences or workarounds or had the same issues.
No, I think to be fair, I don't think these like the non AKS resources are designed for anything other than TCP. I think it's limited to Nginx in some way. I'm not 100% sure, but that might be the reason.
Yep. Thank you. Great presentation, Mohit. Thank you.
Thanks, Eska.
And then there is another question here. So how do you compare Azure Functions versus ECS container instances, making API calls externally monitor blob availability? Okay, it's a really specific question compared to others. Do you want to
I'm just yeah, I'm just reading
pitch
the
in?
questions. Give me one
Yeah.
second. But if you're going to run an API call, that's an HTTP and HTTPS. But depends on how auto scaling. If you want auto scaling, just go for function apps. I don't think you should be overcomplicating things.
Yeah, not sure how we should answer that question. Do you want to pitch in and elaborate a bit on the question there?
Madhumita, you can unmute and talk about this.
Sorry.
Yeah.
Yeah, I think scalability point is valid. Okay, yeah, we can use Azure functions. It's just I was just trying to compare. If we just want to make an API call, would it be better to use functions versus container instances?
Functions are designed for HTTP, HTTPS, the web apps functions.
Yeah. Okay.
You probably should go for that if you're making an API call over the internet, which probably is HTTP, HTTPS.
Right.
Yeah.
Yeah.
Thank you.
Any other questions, or do you want to wrap up? I will at least stop the recording, and then I have to thank